Hello friends, welcome back to EPG Pathshala. In the previous modules, we discussed the anatomy of the classes. We learnt about static data members, we learnt about nested classes, local classes and few other things about classes and objects. Now, in this module, let us learn little more about classes and objects. In this module, we will discuss how the assignment of objects takes place, how we define array of objects, how we define pointer to an object, what are constant objects and little bit about memory allocation in objects. Well, in the previous modules the classes that we defined like time and student, you may be able to recall that the operations that we wanted to perform on those classes like read time, display time, we wrote functions for them. So, we defined member functions for performing these operations and these operations actually were performed onto the individual members, like read data function would individually read hours, minutes and second and so on and so forth. We would also be interested in knowing that can there be any operation or are there any operations which can be performed in the entire object itself. Well, one of the operations that can be performed onto the entire object itself, you must have guessed it by now. Yes, you have guessed is right. The only operation or the one operation that we can perform on the object, entire object itself is assignment. It is possible for us to assign the object of a class to the another object of the same class. Let us see this with the help of an example. Now, in our time class, we have defined hour, minutes and second as data members and these are the member functions. In the main function, we have declared two objects of time class, namely time 1 and time 2. Now, in time 1, we are reading the data by means of invocation of the function read data. So, this read data function will read some values in time 1. Now, let us say these same values if we wish to assign to time 2, it is possible for us to do so with the help of an assignment operator. Here what are we doing? The time 1 is being assigned to time 2. So, the object time 1 of time class can be assigned to any other object of time class and this is true with all classes, that object of a class can be assigned to any other object of the same class. Up till now, whatever the examples that we have been seeing, we are declaring individual objects. For example, for student class we declared objects like student 1, student 2, student 3. But in real life application, actually in case of student class, if you see, we would like to deal with large number of students. So, we would not be interested in defining individual student objects to store the data of various students. What we would prefer would be that we have array of students. So, that we can do if we are allowed to define an array of objects and we can define array of objects. C++ allow us to declare the array of objects and how do we declare the how we declare the array of objects? Let us again define array of our student class that we have been using. So, here this is our student class that we have defined before. Now, if I wish to store the information of the 30 students that are in my class, if my class has 30 students and if I wish to have an array of those 30 students, what I can do is I can say student, this is the name of the array and here I am specifying that I wish to store 30 student. Now, how do I perform an operation on individual student? Well, as you do it in case of the array of any data type, if I wish to read the information of the first student, I can say student list 0 dot read data. If I wish to read the next student information, I can say student list 1 dot read data. And if I wish to do it for all the 30 students, it is possible for me to write a for loop which runs from 0 to 29 and I can say student list I dot read data. Now, if you look at this student list, you would realize that this student list in itself is an abstract data type. How it is an abstract list of the data type? Well, we can say that as a it's a data type wherein the values that a variable of this type can store is the list of students of some finite length, and there are number of operations that we would like to define on such a data type, like insert student, delete student, search student, sort student list, etc. So, it is possible to define an object MCA of this data type. We may be interested, for example, for a class MCA where we have some 30, 50, 100 students. It makes sense that we have a data type like student list, and then we define an object of that data type. So, let us try to now integrate these things, that we define a student class, and with the help of this student class, let us define another data type called student list. So, what would be the data members of student list? The data member of the student list would be array of student objects. Well, this would be more clear. Let us have an example, have a look at this particular program. Now, this is the student class that we have defined. It has 3 data members, and it has member functions like read data and display data, display header and display. Here we have defined a function display header, because sometimes when we want to display the information of a student, on top of that we would like to have labels like roll number, name and marks, and then we have a function like display, and then we have a function get roll number. What is the purpose of this function? I will tell you. So, this is our student class that we have defined. Now, this student class or the variable of this student class or the object of this student class will be able to store the information of only one student. So, if I want to define the information of 2 students, I need to define 2 such objects. If I want to store the information of 3 students, I need to define I need to declare 3 different objects. So, a student class defines one student. If I need to store more students, if I want to store the information about many students, I need to define many objects of student class. But I also want to define another data. So, student is one data type that I have. Now, I want to define another data type which defines a student list, or which can define a class or a batch or a grade, whatever you want to call it. So, let us try defining another data type now. So, we are defining another data type called student list. What data members it has? It has a data member student list. There is a data member list which is an array of student class and which can have at most 30 students, and I have another data member here size, because as you know that the dimension of array only specify the maximum limit, and we may not always store those many students. So, size will actually store the actual number of student record that we wish to store in a list. Now, in this data type, we would like to define the operations like add student, we would like to define operation like search student, we would like to define the operation like display the student records, and so on and so forth. So, once we have defined this particular class, now I can create an object MCA of type student list. Now, see here, the MCA is actually representing list of students. So, MCA is representing a list of student. So, I am defining a single object, and now this single object is actually defining list of student. Okay. Now, when I define this list of student, if I want to read student record into that, how do I do it? Let us see. Now, have a look at this add student function. What we are doing here is, the size is the index which is indicating the last student in the list, the index of the last student record in the list. So, what we are doing here is, for example, if the size says 30, so I am storing if let us say the value of this size is let us say 10. So, the student record will be stored on the index from 0 to 9. So, if I want to add another student, that I would like to add at the index 10. So, what I would say is list 10 is equal to another student, and now you know that object can be assigned to the object of another object of the same class. So, here this assignment is possible, and then we can increment size by 1 because the size has increased by 1. If I want to display the MCA, the data of MCA, which is the list of students, we can have function like this, wherein we run a loop from 0 to size minus 1, and we can call a display function. Now, this display function is which display function? This display function is that of our student class. In student class, you would recall that we have defined a display function which displays the information of one student. Now, on every array index, we can keep on invoking student class display function which would display the data of that student, and when we increment I, we again call the display function which would be displaying the data of the another students, and that is how we can keep on displaying the another's all the information about all the students in the class. Now, if I want to read this, we can define read data function also over here. Now, read data does what? It reads the size, that is the number of students which we wish to have in the list, and then one by one it keeps on reading the student data here. Now, again this read data is the read data of that student class. So, every time we want to read the information about one student, MCA represent list of students. When we want to read this list, we would read one record at a time, and to read that particular record which is an object of a student class, the read data function of student class can be invoked. And so, here we are invoking the function read data of the student class. Now, you can say that on this MCA object, which is an object of student list class, we can invoke function like add student, we can invoke a function like search student, and so on so forth. What is the need of having this student list data? We could have had a simple array defined in main function called MCA 30 or maybe student list 30. Well, since the list in itself has lot of operations which can be defined on itself, it makes lot of sense for us to define this as a class. What is the advantage? Because once I define this data type student list, now if I have another class with me MTech, what I simply need to do is create another object of type student list. So, I will declare another object student list MTech. If I also have a postgraduate diploma running in my institution and I wish to store the data of the student of that class also, what I simply need to do is I need to create an object PGDCA. I need to create an object PGDCA that would be an object of student list class. So, once I define this data type once, later on as many student lists that I need to deal with, I would simply need to create or define an object of this data type and keep invoking these functions, and I would be able to achieve what I wish to achieve. If I do not do so, what would happen? That I will have to define these functions separately, I will have to define different arrays to represent the list of MCA, MTech and PGDCA, and then I will have to pass those lists to the functions, and the things will be less organized. The moment I create student list as an data type, I define the possible operation that I wish to I may have to perform on the list of the students of a specific class. This job I do it only once, and now for any number of classes I want to have a list and I want to perform those operations, I simply declare an object and keep invoking these operations that I have defined in this particular data type, and this makes the whole job of dealing with my different list of students very easy for me. Okay. We can assign one object to another object, we can declare array of objects. It is also possible for us to declare Well, this is the output that we would have in the previous program. You may have tried a small C++ program by now, and I am sure you must have successfully compiled and executed it. Now, try now, since you have learned about classes and how to use the classes, do try more and more programs for getting a better clarity of classes and the objects, and do write them, compile them and execute them. As I have said earlier also, the best way to learn the programming is to write as many programs as possible. So, wish you happy programming ahead. Now, let us discuss few more things about classes and objects. We can define pointer to an integer, pointer to a float, pointer to a character. In the similar fashion, it is possible for us to define a pointer to an object. How do I define a pointer to object? Almost in the similar way as we define the pointer to the built-in data types. Here I am defining an object T of time class, which we have defined earlier, and here I am defining a pointer to an object of time class. Once I define a pointer to the time class, what does time PTR can store? It can store the address of any object of class time. You may recall that the pointers only store the addresses. So, how much memory will be allocated to time PTR? It would be either 2 byte or 4 byte, depending on how many bytes are required to store an address on your machine. So, I am assuming let us say 2 bytes are required in our machine to store an address. In that case, the time PTR will be allocated 2 bytes. So, it is not going to hold the time object. What it can hold is, or what it can store is, it can store the address of any time object. So, what we can assign into it? Address of any time object. So, let us see this. Here T is a time object. So, I am assigning an address of this object to time PTR. So, now this pointer is pointing to this object. Sometimes we may not want the time pointer to point to some existing object. What we want is that we want a memory for time object to be created and its address to be stored on time PTR. Okay. So, if we want to do so, we can make use of a new operator and get memory allocated for a time object, and the address returned will be stored in time PTR. Similarly, we can create an object of student class and we can create a pointer to student class, and this is how we can make student pointer to point to any existing student object, and this is how we can get memory allocated for a student object, and that address can be stored in student PTR. Well, once we have declared a variable and we have defined a pointer to it, and we have made a pointer to point to some time object. This we would do because we either would want to use this pointer to store some data on that student object, or maybe to retrieve the data that has been stored in that particular time object. So, how do we dereference object pointers? So, let us see how do we dereference the pointer to object. Time PTR, as we have defined, is a pointer to a time class, and you know, for dereferencing we use this star operator. So, to dereference the time pointer also, we can use the time pointer to dereference it. Once we dereference it like this, we will get an object, and then we can use a dot operator and then the member name to which we wish to access. Now, in this case, ours is the data member. So, we will be able to access it like this in any main function or any non-member function, only if it is declared public, but normally we do not declare data members public. So, if it is not public, it will not be accessible, but if it is public, this is how we can access it. Now, using this star and dot operator, this combination of star and dot operator is sometimes cumbersome, because then we have to use these parentheses, and it does not remain very convenient to write and maybe sometimes convenient to read. So, this way we can of course do it, but the more common way which most of the people prefer to do it using this arrow convention or this operator to access the member. So, it could be used also to do that. In a similar fashion, the pointer to object can also be used to invoke the member functions. So, here we are using the time pointer to invoke the read data function. So, here also we can either use the combination of these two operators like this, or we can make use of this arrow operator to access these member functions. In C++, we not only can define a pointer to the object, it is also possible for us to define a pointer to its data members. What does that mean? Let us say in a student class we are having a data member roll number, name, marks. So, it is possible for us to declare a pointer which does not point to the object as a whole. What does it point to? Either to its member roll number or to a member name or to the this. Now, how do we define such pointer? Let us have a look at it. See, here we are defining a pointer RNPTR. So, here we are defining pointer RNPTR, but this is a pointer to what? It is pointer to the roll number member of student object. So, it is not pointing to student object, what it is pointing to? The roll number member, data member of the student object. Now, since we are defining it, now whenever we define a pointer variable, we need to define that to what kind of value it is going to point to. Since we want to define a pointer to point to roll number and the roll number is an integer value, this Rn pointer is being defined as a pointer to integer, but it cannot point to any integer, it can only point to a integer data member of student class. Therefore, here we are making use of the scope resolution operator along with the class name to indicate that RNPTR can point to any integer data member of student class, and here we are initializing it with the address of the roll number. If we have any other integer data member in the student class, we can initialize RNPTR with the address of that data member also. Now, how we would use it? Let us say we define object student S. So, if I want to refer to roll number, I can say S dot roll number. Again, here the condition applies that the roll number has to be public, then only we will be able to do it in the non-member functions. If it is a member function, then we will be able to access it like this. So, to access roll number, I can say S dot roll number. If I wish to refer to or access this roll number using this pointer, I can also say S dot star, because we are dereferencing RNPTR is equal to 10. Any pointer actually stores the address. So, when we define a pointer to the member function, again we believe that we are storing an address, but here there is little difference. The pointer to the data member is little different from pointer to object or pointer to any other data type per se. What is the difference? The pointer to the member of a class does not really hold the absolute address of that memory to which it is pointing to. What is pointer to the data member of a class stores? It only stores the offset of the member to which we are making this pointer to point to. Let me explain it more precisely. Well, pointer to the member of a class does not contain absolute address of the member, it only contains the offset of that member within the object of that class. Now, what we mean by this offset? Now, see, if I declare the variable of type student which has 4 data members, roll number, name, marks obtained and max marks, this much memory will be allocated to that object. If I define a pointer to object or the address of the, or in general if we talk about the address of this object, we refer to the base address of this object. This object would be occupying number of bytes. So, address is only the address of the byte from where this object is being stored. Now, within this object the offset of roll number is 0, because from where the object is getting stored, the very first location only the roll number is stored. So, the offset of roll number is 0, and if you assume that the roll number occupies 2 bytes, in that case the offset of name is 2, and if I assume that name occupies let us say 40 bytes. So, 40 plus 2, the offset of marks obtained will be 42, and if the marks obtained again occupies 2 byte, in that case the offset of max marks will be 44. So, what does the pointer to the data member stores? It only stores the offset of that data member to which it is pointing to within the object, and you would see that this offset for any data member will remain same for all objects, because if I define another object, roll number would again be stored as the first member, name second, this third and fourth. So, within any object the base address of object would be different, but the offset of all these data members within that object will always be same. So, therefore, what we are saying is that when we are accessing it, we are accessing it along with the object. So, with the help of the offset address of the offset and the base address of the object, it would be possible for us to reach to the member to which we want to refer to. In the similar fashion, it is also possible for us to define the pointer to the member function. So, as we have defined the pointer to the data member, in the similar fashion we would be also able to define the pointer to the member functions. I would like you to explore it yourself and try defining a pointer to the member function of the class. To understanding concepts and to learning, it is also important that you try to explore number of things at your end as well. So, this is one exercise that you do it on your own and try to implement it. Everything that you have learned, always try to implement it in a program, so that you are able to see that you have understood everything correctly or not. Well, when we define a variable, we can define the variable as a constant. Constant variable, as you know, can be initialize the value in the beginning, and later on the values cannot be changed. So, as we can define a constant variable, it is also possible for us to define a constant object. Now, what would it mean to have an object as constant? What is a constant object? Well, a constant object is the one which cannot modify itself. So, when an object will not be able to modify itself, let us have a look at this particular time class. See, if you look at the members of this class, out of these 4 functions, one of the function has been defined as constant function. When in the next module we would start discussing functions, we will discuss more about the constant function, but as of now what you can understand is that a constant function is a function through which the member functions cannot be modified. Okay. If an object has, or if a class has at least one constant member function, it is possible for us to define the object of that class as constant. Now, for example, here we have defined this time 1 object, which is the object of time class, as constant. Now, when we define this object as a constant object, it means that this object will not be able to modify itself. When it will not be able to modify itself, see, any operation that we perform on the object is through its member functions. If I define this object as a const object, when I try to access read data through, sorry, this is time object, please ignore this one. So, this is time. So, when I try to invoke this read data function on time object, this will not work. Why it will not work? Because read data function, again instead of read data we are having a function read time here. So, refer to this as a read time. Now, this read time function is not a constant function, therefore, this cannot be invoked on this time object. But display time is a constant function, and a constant function is not capable of modifying the data members, therefore, this constant member can be invoked on the time object. So, we will revisit the constant objects when we discuss the functions in the coming modules. At that time, we will revisit the constant objects and we will try to have a greater clarity onto the constant objects. Now, let us have a look at the memory allocation aspects of classes. In C, you know that how the memory is allocated for the variables. You know, every data type has its fixed defined amount of memory that can be allocated to it. Integer gets 2 or 4 byte depending on machine, character gets 2 bytes or 1 byte depending on machine, and so on and so forth. And if I define an array, so the number of elements that I have in array multiplied by the type of the element, I mean the size of the type of the element whose collection that array is, that would be the size of array. When we try to compute the memory required for an structure, the memory allocated to a structure is the sum of the memory of its individual members. Let us understand what happens in case of the classes. Why it is necessary to discuss? Because you know that in classes we have data members, we also have member functions. So, when I declare an object, how much memory will be allocated to an object? Well, in case of classes, the memory allocation happens in two phases. When the class is defined, the memory to member functions and static data members is allocated, and they remain in existence during the entire execution of the program, and this memory is not allocated in object. So, why it is not allocated in object? Because they are common to all objects of that class. So, here what we do is whenever the class definition is being found, the memory is allocated to member function and static data members. Now, once we define the class, we may declare the object of that class in different functions and different places. So, whenever a declaration of object is encountered, the memory is allocated for all non-static data members. So, the total amount of the memory that will be allocated to object would be the sum of the memory needed for each data member. So, in my class if I have 4 data members, then the memory that will be allocated to object would be the memory required for the first data member plus memory required for the second data member plus third data member plus the memory required for the fourth data member, and this memory will not remain in existence for the entire duration of the program execution. For how long this memory will remain in existence depends on where the variable has been declared. If it is declared local to a block, its lifetime will be only that duration for which that block is executing. So, the lifetime of the memory, which memory? The memory that has been allocated to non-static data member, or what we call is object, will be remain in existence till the block in which this object is declared executes. So, now we have discussed about the in this module and the previous couple of modules, we discussed the anatomy of basic anatomy of the classes, and what we have seen here is that the classes are powerful tools to create your own data type, and if a class is properly defined with the proper access specification, they help us to achieve object oriented concepts like abstraction, encapsulation and data hiding. And when we achieve these or when we implement these object oriented concepts, when you would start writing program, you would realize that all of these things make your program very manageable, and if we write it without classes and without these object oriented themes, the application, maintaining such application is more cumbersome, and when we thoughtfully create good classes and we organize our program in form of correct identification of the classes, the application becomes far more maintainable. Now, up till now we have seen that the object of the classes we perform only one operation like assignment, but rest of the operations we cannot perform, and which makes our data type little inferior to the inbuilt data types. But C++ provides lot of features which can help us create our own data type as powerful as inbuilt data type, or it allows us to create a class in which the variables or the objects of these class we would be able to use in almost the similar way as we are able to manipulate or use the variables of the inbuilt data type. So, with this much understanding of classes, now you are in position to write simple programs. So, do try programs where you create your own class. Think of some data type that you would like to use it in your or whatever. Think of a particular program that you want to write and identify what kind of data types it needs, and implement those data types using classes, and then try to write that particular program. And when we meet in the next module, we will talk about the functions in C++. In C++, we have various flavors of the functions that are available, and there are a lot of things which we need to understand about the functions. So, all those things we would do in the next modules. So, be there when we for learning those functions. So, see you in the next module. Till then, bye. Till then, bye.